Welcome, everybody. Good afternoon. I'm Mary Sue Barrett, President of the Metropolitan Planning Council, and we're delighted that you chose to spend your Thursday lunchtime with us. This is something we do regularly, roundtables, to convene thinkers and doers across sectors, across issues, to make our region more livable and more competitive. That's essentially our mission. And as good as social media is at connecting us, there's nothing like getting in the same room, learning together, grappling with tough challenges, and examining the potential for change, for opportunities to implement change in our metropolitan region. So we're excited about having had the chance to do that for 78 years. We do research, advocacy, and on-the-ground demonstration projects all about improving this region's vitality. So we steal ideas regularly from other places, and we're delighted we have this terrific panel to help us here today. You'll take a look at how we titled today's roundtable. It's called State of the Smart. So what does that mean? First of all, we're going to have a no lingo rule here. So any lingo, you can shout it out. Lingo alert if you hear one, and we'll pause and define it. But one of them, you're going to pick up some lingo here today. One of the terms that's used if you're not a transportation guru is ITS, Intelligent Transportation Systems. So essentially, if you're not doing intelligent transportation systems, you're doing dumb transportation. We don't want to be on that side of the ledger. We want to be on the smart side of the ledger. But it's also a rapidly changing environment. So state of the smart is rapidly evolving. We need to hear from the best in the business and evolve in our region. So that's what today is about, being inspired by other regions, other applications, and thinking hard about how we put those to work here. So when you think about this discussion, and MPC's tried to make a contribution to it just this week, this is the third in a series of events that we've done as part of Chicago Ideas Week. There are, if you're not aware of the lineup, there's a wealth of interesting discussions happening throughout this week. So we know we're competing against other interesting things, and I'm particularly glad that you're here. Transportation benefits by how technology is impacting other industries as well. When you think about technology's power, it's about engaging people differently, engaging different people, more people. It's also about equipping us with the tools to analyze the data that's impacting communities, improving those communities, changing those communities. So it's both getting the human element together, but also the information component so that we can act on those trends. A third way that technology impacts our lives and the transportation sector is that it can dramatically affect efficiency and maximize efficiency. When we can't build our way out of traffic gridlock, we obviously need to get smarter and look at ways to maximize throughput, carrying capacity of our transportation infrastructure. It's that last one that we're going to focus on today, but within the context of remembering the power of technology to bring new people into the debate and to enable different kinds of solutions. We had an event Monday night. We had a roundtable at noon on Tuesday, and a couple of takeaways having had the chance to sit through those is one of our speakers admonished us to always remember to ask, where's the fun? Which is an element that sometimes gets lost in transportation technical conversations. But when we're improving things, we should make sure that they are engaging and enlivening and adding to the vitality of our region. So remember to ask, where's the fun? And also to ask, who's being heard? So that's, again, about this power of technology to democratize and broaden participation beyond people who can show up at a public hearing. So we're focusing on the efficiency side today of intelligent transportation systems, and the power is clear. It's clear in our own region in some of the applications, and definitely the inspiration that we get from elsewhere. It can improve traffic flow, decrease delays, give riders up-to-the-minute information at a relatively low cost. So what are some examples from our own region? I'm sure they're ones that you are benefiting from. CTA's bus and train tracker is one of the single biggest applications anywhere when you look at clicks and traffic. It's dramatically increased convenience and predictability for riders. The Illinois Tollway's iPass, electronic tolling system. Again, wildly popular. Participation rates are very high, and it does both improve congestion and saves time for drivers, so it's that convenience factor again. Next summer, Chicago will become the largest city to adopt an open fare system for transit, so that's going to be an important one for us to watch. CTA and PACE are collaborating on a system called Ventra, and what they're going to be able to do is offer we riders a new fare payment system. The concept is that instead of carrying around a bunch of different cards, you can have one card and with a tap pay for your transit and same card pay for your groceries. So it's simple, preloaded, and it's coming along as a solution at the exact time that the CTA was going to have to look at modernization and replacement of their existing fare medium. So it will save us time as riders, but it will also save the system money. CTA has been working with Cubic Transportation Systems to design and implement this new system, and it is estimated to cost about $450 million over the 12-year contract and produce savings of more than $50 million to the CTA. That's a big deal at a time when we're looking at enormous maintenance as well as strategic system expansion needs that are unfunded. So these are just a couple examples, some in place, some on the horizon that could help us understand the potential and explore others in our region. But there is tremendous room for growth, and that's what we're going to look to our panel to help us with. Some of the things on the horizon and also on MPC's work plan are congestion pricing that the Tollway has embraced with their funded, we always love to talk about projects that are funded, I-90 or Jane Addams reconstruction. They are, just steps away from the full authorization and launch of congestion pricing on an ad lane, and that would have the capacity to also incorporate transit. Variable price parking has potential in our region, but is not currently in place. Time of day of the week, all things you can alter. Just this morning, CMAP, in approving their next round of technical assistance projects, awarded one grant to the Bucktown Chamber for a variable priced parking pilot. And CMAP and MPC are delighted to be collaborating with local leaders in Bucktown to learn about this. With the city's new pedestrian plan, there's also some exciting possibilities to dynamically time crosswalks so that we start to not just prioritize cars, but prioritize people, the pedestrians. Transit signal prioritization is already in place on some major commercial streets like Western Avenue, and with the potential for bus rapid transit on either Western or Ashland, that is really a necessary precursor for bus rapid transit, and the possibility of those two things being deployed to deliver a new form of transit is very exciting. So these are all things to whet our appetite about what more we can do. So our speakers have experience from around the globe, literally, other regions, other cities, who are proving the potential about intelligent transportation systems. Some of the things you'll hear about are congestion pricing, variable price parking, pricing, and smartphone applications. What I'm going to do is, first of all, encourage you to remember your survey form before you leave. We're going to hear from each of the panelists about 12 minutes each, and then we should have sufficient time when the three of them are done with their discussions and presentations to open it up for you to engage with them. We are being recorded, both audio and video. We are live streaming on MPC's website right now, and we are also being recorded through our partnership with Chicago Public Radio, WBEZ, Chicago Amplified. So that is a great partnership. It allows you in both forms to share this information with folks later. And also, we're excited that this roundtable was plugged on Politico.com this morning, so there might be people from around the country joining us as we learn today. We're going to start our discussion with Naveen Lamba. Naveen is IBM's Intelligent Transportation Guru. That's a new title I just gave you. And we have had this wonderful partnership with IBM. Locally, Jody Samsa, the city's current our new chief technology officer, used to be at IBM, John Tollway. We've worked with lots of your colleagues and are delighted to have you joining us today. Naveen runs global business services for IBM, and what he's going to do is help us understand how he's helping some of his clients use technology to better manage fleets, other assets. There's some really cool technology if you're about to purchase new fleets where you can actually track that, which we'll hear about. And while that might not exactly sync with Chicago's fleet replacement timetable, what I think we can learn is a lot about asset management and how technology can help us control and get ahead of the curve on those costs. So please join me in welcoming our first speaker, Naveen Lamba.
Thank you, Mary Sue. Good afternoon, everyone, and thank you for coming. Thank you, Mary Sue, for kind words. So today I'm going to talk about, what are the industry challenges that, a lot of the transportation leaders face. And, while we can talk a lot about different types of solutions, a lot of new things, today most cities, most agencies are struggling for funds. So I'm going to focus on one type of solutions that we focused on, which helps reduce the cost of, running an agency, running a, assets are the biggest line item in terms of where money is spent. So if you think of a DOT or a transit agency, the biggest expense is managing their fleets, managing the roads, the rail, keeping it in a state of good repair. So what types of solutions can we deploy that will not only do that better, but hopefully help achieve those things at a lower price point? And I'll give some examples of where some of those solutions have been deployed. So as I said, there's this big, everybody's faced with this, the need to do more with less. There's all sorts of increasing demands on what needs to be accomplished. The infrastructure and our assets are aging. We're not able to buy as much as we would like to. There are lots of new regulations, new safety standards that need to be conformed to. There's customer expectations. With smartphones, everybody wants, all the right information. It should be here now. It should be accurate. It should, the demands are going up significantly, while the resources to do all that is actually going down. So there's a whole list of things. I mean, there's a rapid pace of change. So even if you adopt new solutions, you're always behind. There's always something new out there that you could have done better. So there's always that pressure to continue to innovate. There's lots of data that you can use to do things better, cheaper, and so on. So net, there's a lot of demands. And when Mary Sue said that, somebody said, where's the fun? I heard it as, where's the funds? Right? So, we all know that's a big challenge. So what do we do about it? So lately, what's happened is the physical domain, the roads, the bridges, the rolling stock, so on. There's a lot more instrumentation, so a lot more sensors, a lot more data that that infrastructure is able to produce, and that when you combine it with the traditional digital domain, the ability to do all sorts of analytics on data and identify inefficiencies, build solutions to fix those inefficiencies. So this convergence or this overlap between the physical and digital domains is allowing for a whole new set of solutions that were not as practical, not too many years back. So now, by pulling in all this data that comes from all these different types of sensors, you're now able to look at your systems, whether it's rail, road, airport, so on, not only as a system in itself, but as a system of systems. You can look for extracting efficiencies across those different types of networks, which traditionally have operated within their own silos. But now there's a lot that can be done in a more integrated, coordinated manner, and I'll give some examples of that. So what is all this instrumentation? What does this allow us to do, or what are we hoping to achieve by doing that? One is visibility. What assets do we have? Where are they? What state of repair are they in? How much are serviceable? How much are not? Just being aware of what you have and in what condition is it. So where do you have? Who's using it? What does it cost to keep up? So just visibility into what is it that you are looking at, and once you know that, then you can look to improve from there. So what's your starting point? And once you know that, then how can you control? How can you start improving? How can you start standardizing across different domains? And then, again, moving on that continuum, how do you start then, automating things, getting cost out of the systems, getting some efficiencies across domains, and so on. So those are the types of things that you're able to achieve using some of these newer approaches that I'm going to talk about. So wanted to give some real numbers, and this is an external, Gartner Research had put out some of these numbers a while back, that what type of savings can we expect to achieve, by deploying some solutions like I'm going to talk about. So from a labor perspective, asset availability, how quickly can you repair something and put it back in service? Warranty recovery. I mean, it's amazing how much money is wasted in repairing things that are actually covered under warranty just because that awareness wasn't there. So there's a number of these categories that they had estimated. And based on the projects we have done across the world, our numbers are are quite consistent with that. So, these are various examples of actual projects and the actual savings that have been achieved along different types of scenarios. So as you can see, this is money that's actually being spent today. And what I'm going to show you some examples of is how can we do the same things and extract some money out of that so that that money can be used to either improve service levels or apply it elsewhere to somewhere else that money could be put to good use. So the first example I'm going to use is with WMATA, which is the Washington, D.C. Metro. What we are doing there is a mileage-based maintenance. A lot of transit agencies do calendar-based maintenance. And while this concept has been talked about a lot, where you do actual usage-based maintenance, when you do the research, actual implementations of this concept are very few. So what we're doing here is instrumenting their fleet with various types of sensors that measure actual use. So every evening when the train pulls into the yard, there are readers that extract information from those sensors as to how much were different parts of the vehicle used, and based on that, estimate what type of maintenance needs to be performed at what point in time. So that you are doing maintenance based on what's required, based on the usage of those components, as opposed to every 1 month, some certain type of maintenance needs to be done every 3 months, every 6 months. So instead of a calendar-based maintenance schedule, it's based on actual usage of those assets. So there's a lot of savings that we expect to achieve here. So this gives a quick schematic of how it works, and there's those sensors. When it pulls into the yard, the data is pulled in, and based on that, what type of maintenance would be required at what point in time, that schedule is created. It also has something called asset configuration management, which keeps track of, again, what part was used, how much, when was it maintained, who maintained it, what repair was done, what was the result of that repair, all of that, so that there is the auditability, and you can go back and see, how were the assets maintained, if something went wrong, what kind of repair was done on it, and so on. So that's also part of this solution. Another one is something called dynamic inventory optimization. So a lot of the larger transportation agencies, a lot of the big transit agencies, there's a big holding cost of inventory of spare parts because you're expected to, as cars come in for repair, you need to repair them and send them back into service quickly. So you need to maintain a certain level of inventory. What this project attempted to do is to how can we reduce the amount of inventory without affecting service levels? It's been used in a lot of places, and we've been able to get huge reductions in inventory holding costs. So that not only gives you a one-time influx of money where you hold less costs, less inventory, but over time, it's that much less you're holding every year. Again, there are some metrics with that. We've number of projects that we've done, we've been able to, the type of results that we've gotten are pretty significant. I mean, 20 to 50% reduction in inventory. And in many of these cases, inventory is as much as $100 million worth. So you can see that when you add that up, it's quite a bit of money that gets freed up to do various things. This just gives a little more, in the interest of time, I won't spend too much time here, but it helps achieve strategic, tactical, and operational efficiencies as to basically how much of what type of part do we store and where do we store it, and based on expected demand, it looks to optimize that so that you are not compromising on service levels, but are able to achieve those targets while holding lower inventory. And again, this a specific example with the LAMTA, where they said, okay, here's 16 million worth of inventory, and show us what you can do with it. So we've achieved significant savings there, and now they're looking to expand this solution across the entire enterprise. The last example is something I'm very excited about. This is something very new, and I'm sure you'll be hearing a lot more of this in the coming weeks and months. Something called Planning Analytics for Asset Lifecycle Management, or PALM. What this attempts to do is take the, what are all the assets, not just in, across roads, rail, water, sewer pipes, utilities, etc. You can add as many of them as you want. Again, where are the assets? What state of the life cycle are they in? What type of maintenance is planned at what point in time? What is the probability that they will fail next year, the year after? So every agency does this to some extent, but when you combine it across different domains, you get a very interesting view of what are the synergies across them. So again, you've got data coming in from a variety of sources. These are the 5 big modules that it goes through. And actually, maybe the next slide will make it a little more clear. What do you have and where is it? What state of repair is it in? What is the predicted performance? When will it fail? What is the probability it will fail next year or the year after, and so on? And again, matching that across domains provides some synergy. Based on that profile of what things will fail, what are the needs? What do you need to fix when? On the roads, do you crack fill, or do you resurface, or do you restripe? What type of treatment do you give so that you can achieve the most benefit with the lowest price point? Once you have the needs, then you identify specific projects that you will take on. And then the last one is investment planning, where you say, okay, these are my needs. These are the projects I need to do. How do I fund them? What is the color of money? What sources of funding should I use first? What do I do next? And so on. This is the last slide here. It just gives the same thing in some pictures. This is the first one, which tells you what assets do I have, when were they built, and so on. What is the probability of failure of different types of assets over time? And then this attempts to synergize across different domains. And then so if there is you're planning to resurface a street, and the water guys are planning to redo the pipes. So can you push back resurfacing 1 year so that next year when the pipes are being replaced, you do it at the same time, save a lot of time, save a lot of money, save a lot of hardship for the travelers on the roads, and so on. And then lastly, a lot of financial planning as to how do you fund all this, and what savings do you get by synergizing the asset maintenance across domains. So just a few quick examples of the types of things that we can achieve. Again, looking at money that's already spent today, how do you do that within your existing budgets? Thank you.
Terrific. Thank you. That was fascinating, Naveen. It's everything from the mundane warranties to looking at usage-based maintenance schedules, and then the power of tying it all together in this POM-type system. It's what taxpayers, of course, expect us to do. I saw almost every head nodding when you gave that last example of the water and sewer pipes and the transportation resurfacing. It's so true. We expect government to be efficient and coordinated, but we need technology systems to help us achieve that. So thank you for showing us what's possible. Invite up to the podium Stephen Mortensen. Stephen is another expert we are delighted to have with us today. He works for the Federal Transit Administration, and FTA, as it's known, has asked him to run their Integrated Corridor Management Program. We've been very interested to follow the implementation efforts in some of these cities. You'll hear perhaps about Minneapolis, St. Paul, Dallas, San Diego are some of the places that have saved money and time in implementing this partnership with FTA. So thank you, Stephen, for making the trip out here to join us.
Thank you, Mary Sue. Good afternoon, everybody. As Mary Sue said, I'm Steve Mortensen. I work for the FTA Office of Research, and I am one of 4 individuals that manage the ICM initiative. 2 others are in the Research and Innovative Technology Administration, Brian Cronin and Dale Thompson, and then my counterpart in the Federal Highway Administration, Bob Sheehan. So I'll provide you their contact information at the end if you'd like to contact them. So I think I have a few too many slides, so some of my slides, for the sake of time, I might gloss over to stay within the time frame. Okay, and also I've been warned about the use of acronyms, so we have lots of acronyms in ITS. I'll try to do my best about that. So what is ICM? I want to make sure that everybody understands at the high level what it is. So essentially it's the integrated management of freeway, arterial, transit, and parking systems within a corridor using ITS technologies and innovative strategies. It includes not only technical integration and operational integration, but institutional integration. So simply put, it's the management of the corridor as a system, as opposed to the more traditional approach of managing the individual assets or networks within the corridor, such as transit facilities or freeway or a highway, arterials. So what is an ICM system then? Well, an ICM system is a set of procedures, processes, and information systems that support transportation system managers in making coordinated decisions involving optimizing the performance of the corridor as a whole. ICM includes the management of demand within the corridor and then also potentially balancing the loads. So you might find that some of the parallel arterials have spare capacity, or the transit facilities within the corridor have excess capacity. So the goal is to try to shift some of that capacity over there. So like I said, it includes trying to shift people to the transit mode, shifting drivers to other routes, especially if there's a major incident, for example, on a freeway, and then also providing good traveler information so people can, if they know that something's going on within the corridor, they can shift their departure or arrival time. So ICM is not only the, managing or responding to when you have incidents in the corridor, but it's also managing when you have construction in the corridor, or if there's special events such as sporting events or concerts, things like that, or if you have bad weather, for example, if you have an ice storm or something like that. Okay, I just want to provide some examples of some supporting ITS technologies and some strategies. So active traffic management would fall within this area. Managed lanes, such as HOV lanes, high occupancy vehicle lanes, and then hot lanes, high occupancy toll lanes, congestion pricing. So what you could do with that is, if there's an incident, maybe lift the capacity, the number of occupants required in the HOV lanes, pricing, shifting the price that's required. And then also operating express or BRT service within those managed lanes. Transit signal priority, Mary Sue mentioned that earlier. And so you could have transit signal priority in and around transit facilities, such as the park and ride lots, or also down a major arterial to try to incentivize people to take transit. And the key one here is actionable multimodal traveler information. Here, actionable. It's not providing information like we have in the past where, say, there's congestion ahead. Provide them travelers additional information so that they can act on it. So it's providing pre-trip and route traveler information via 511, over the phone, over the internet, web-enabled handheld devices, and also the infrastructure such as dynamic message signs. So it would include route alternatives, mode alternatives, comparable travel time. So travel time on the freeway versus the managed lanes, transit facilities, and arterials. Real-time traffic signal coordination. So if you have a goal of trying to shift the traffic from our freeway to an arterial, implement some type of capability to change the signal timing plans in real time so that you can increase the capacity. And then integrated electronic payment. So integrating transit payment along with the tolling so that people would have one account. Transit agencies might lower the fares if there's a major incident to try to shift people over to transit, or there could be some type of incentive program that if people take transit frequently enough, you might give them a credit so that they could use the price lane some other time. Quickly, there's two major goals of this initiative. One is to demonstrate and evaluate strategies and ITS technologies that help transportation operators efficiently and proactively manage corridors. So we're working with a number of sites to do that. And then all the knowledge that we've gained and some of the tools we've created for this, we plan on providing to practitioners so that they can apply that for their own corridors. There are 4 phases to this initiative. We've completed phase 1 a long time ago, which was the foundational research, essentially doing an assessment of what is the state of the practice of corridor management in the United States and identifying a number of supporting ITS technologies and strategies. Phase 2, corridor tools, strategies, and integration, has 2 major parts. The first one was we developed a methodology for modeling ICM, and I'll go into some of the specifics in a few minutes. And then also conducting research to identify ICM needs and some issues. For example, we found that working with 8 of our pioneer sites that there were some data gaps, and I'll touch on that in a few minutes also. And then also identifying performance measures and doing some research with respect to decision support systems. Kind of the heart of the initiative is phase 3, and it has 3 stages. The first stage, we selected 8 pioneer sites. I worked with them to develop their concept of operations for ICM and then also to develop requirements for them. Then moving to stage 2, we selected 3 of those 8 sites to apply that method, the modeling methodology that we developed in phase 2 to model their ICM concepts. And then finally, stage 3, we selected 2 of the 8 pioneer sites to deploy their ICM system and to demonstrate and to evaluate it. And finally, phase 4 is our outreach and knowledge and technology transfer activity. It initially was to provide awareness that this initiative is going on. We've moved beyond that, and we've gained quite a bit of knowledge, and we're trying to share that with communities throughout the United States. So here quickly are our 8 Pioneer sites. If you have specific questions about them, I'd be more than happy to entertain them at the end of at this roundtable today. So the three here in that are italicized in our blue, those were the 3 sites we selected for modeling. The 2 sites we selected for demonstrating ICM include Dallas and San Diego, and I'd like to state that for all of these sites, they included a state DOT, municipalities that operated the arterials in the corridors, and 1 or more transit agency. And the Dallas team is being led by the Dallas Area Rapid Transit Agency, and San Diego is being led by their Metropolitan Planning Organization. So quickly, this kind of shows kind of the breadth of the different types of networks in the corridors. They included, again, freeway, arterial, and transit networks. And this slide here, what I want to bring to everyone's attention is we identified what we thought would be performance measures for the arterials, transit, freeway, which is not included here, and then also at the corridor level. And we found out that the Pioneer sites were not able to monitor in real time those that are in bold. So most of them were not able to monitor the travel speeds on their arterials in real time, and we thought that was important. And then also to be able to monitor the usage of their park and ride lots at transit agencies in real time, as well as how many people they have on their buses and trains, because you need to be able to do that if you're going to recommend for people to switch to transit. Okay, moving on to phase 2, our analysis, modeling, and simulation. These are some of the reasons why we think it's important to model ICM before you go and deploy it. But I just want to point out a couple things that we learned in going through this exercise. We found out that to do the modeling for particular operational conditions, and what I mean by that is a mixture of whether you have low or medium or high demand on your freeway in particular, or if there's a minor or major incident, you need to know the right combination of strategies that will optimize your corridor. So modeling helped our sites to determine what those are. In fact, there's a matrix that they put together that shows exactly what strategies they used for each of those combinations of operational conditions. And then we also found that where they were proposing to implement some strategies, they found out if they did it for a particular operational condition, it was counterproductive, and it was kind of counterintuitive. So that was very helpful to go through the modeling phase. So the methodology that we came up with was actually to take what is currently out there in the modeling community and to integrate them. So integrating macroscopic models, mesoscopic, and microscopic models, because each of those have kind of a unique ability. But when we selected the 3 AMS sites, not one of them included all 3 of those. They all needed to have the macroscopic model, but in 2 of the cases, they integrated the macroscopic and their mesoscopic model, and in one case they integrated the macroscopic model with the microscopic model. I know this is probably hard to see, and I won't go into details on this, but these are the strategies that each of the modeling sites selected. But I will kind of go over kind of the groupings of those strategies. So each of them came up with some specific strategies for excuse me, enhanced traveler information. 2 of them are the 2 demonstration sites, actually, Dallas and San Diego, will be implementing a decision support system that they're developing. Minneapolis went with a kind of a lower tech approach of kind of a data exchange. A number of traffic management schemes, hot lanes in Minneapolis and San Diego, and then transit management strategies. Such as, like in Dallas, they're implementing parking management, so they'll be able to monitor the capacity or the real-time capacity or utilization in their park and ride lots, increasing their capacity on the transit lines for it. So Dallas is planning on actually adding rail cars or trains if there's a major incident. They were planning on being able to do that during peak hours and off-peak hours, but we learned currently that their headways are such and the lengths of their vehicles are too great, so they can't do that during the peak. They'll only be able to do that during the off-peak. And then station parking expansion. Dallas is planning on, if their park and ride lots fill up, they plan on contracting with private property owners, such as Walmart or something that might have some spare capacity, and then they would direct people to park at those spaces and then shuttle people to their park and ride lots. And they even had an innovative idea of having valet service, where you would just pull up to the park and ride lot or the light rail station, and then somebody would park your car for you. Unfortunately, they're not going to be doing that in the demonstration. All right, so some values that we calculated. These are the 4 major performance measures that we used in the modeling. Travel time savings and improvements in travel time reliability, fuel saved, and then a reduction in emissions. So here are these values. Just a disclaimer, Dallas's corridor has a larger travel shed, so that's why some of their numbers came out to be a little bit larger. We did a benefit cost analysis also. So we calculated over a 10-year period the net benefits. So we assessed what the costs were, the capital costs and recurring annual costs. The benefits, annualized them. And again, Dallas had a $264 million net benefits over a 10-year period. And then we also calculated the benefit cost ratio. Again, Dallas had the highest one. Minneapolis came in second because their costs were a little lower. All right, so these are the specific, some of the specific strategies that are going to be included in the demonstration site. So both, again, have a decision support system. They're both going to be providing actionable traveler information, including comparable travel times. San Diego has managed lanes, congestion pricing, Dallas has HOV lanes. Both plan on rerouting their traffic to their major arterials that are in their corridor, and then mode shift to transit. San Diego is going to be implementing a premium BRT system in their corridor. Dallas currently has a red line, an orange line, light rail system in the corridor. Implementing parking management, I talked about that earlier. Talked about the real-time service adjustments, and San Diego will be implementing transit signal priority. So along with the demonstration, we've hired Battelle to conduct an independent evaluation. So we've identified a number of high-level hypotheses, and then for each of those, we have an analysis area, which are listed here. So we have already started collecting the baseline data, and I'll talk more about that in a minute. So just one last plug here for the Phase 4 is our knowledge and technology transfer. The Federal Highway Administration is going to be funding a number of workshops across the country of those sites we've adopted or identified as early adopter sites, and Chicago is actually one of them. So we have a modeling workshop that's planned for December. So we're working with the MPO here to set that up. Federal Highways also has some funds for some peer-to-peer support if any localities want to get together with the demonstration sites for them to share information. We've provided a number of presentations at conferences. The most recent one was at ITS America's annual meeting. We have a number of webinars, and then we have a knowledge base, which is basically some web pages on RITA's website. And we've developed 2 guidance documents, which we'll be posting soon. One is on analysis, modeling, and simulation, and the other one is on implementing ICM. We also have the concept of operations and requirements that we've posted there. We've written a number of magazine articles. The most recent one was ITS International. We have a periodic newsletter. You can sign up to receive that. And I encourage you to go to this URL here to find out more about the initiative. Almost done. So our next steps...
We'll let you talk about this in the question and answer, too.
Okay, great. So again, the AMS and implementation guides, we'll be posting those soon in the knowledge base, as long as other documents that we posted here, the Stage 2 documents. Dallas has completed its design. San Diego is going through its critical design review later this week, so they're currently going to be building their systems. Both will go live early next year, March for San Diego and April for Dallas. As part of the independent evaluation, we started collecting a year's worth of baseline data. The demonstration will be for an 18-month period. So we'll have a 6-month shakeout period, and then so we'll be collecting some after data as well. And then again, we'll be planning on conducting these early adapter workshops and peer exchanges. So if you have any questions or want to find out more about this initiative and the work that we're doing, please feel free to contact any one of these project managers. Thank you very much. You're welcome.
Fascinating stuff again. I know I rushed you, but we will. I'm being jealous and guarding our time for Q&A because I know people are going to want to follow up to learn more about that. One of my pet peeves is when I listen to the traffic reports on a radio station and they don't also provide comparative data on transit. You know, the Kennedy is backlogged, blah, 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 blah. Well, what's the blue line? So this shows you what's possible. And I think all of us from this region would raise our hand and volunteer to be one of the next test areas because we are have many, many layers of transportation decision-making agencies in our region. So coordination is a massive challenge everywhere, and particularly here. Our next and final panelist, I'd like to welcome Balaji Prabhakar, who is a professor of electrical engineering and computer science at Stanford. You're going to help us go global here. We're delighted that you've added us to your stops as he works around the globe, places like Singapore, Silicon Valley, India, etc. And we're really interested to hear more about how you're combining smartphone apps with incentives, and the underlying goal is to help people change behavior, whether it's mode shift or other types of different outcomes that can be influenced by deploying technology differently. So thank you for joining us, Balaji.
Hi, good afternoon, everybody. Thank you, Chrissy and Mary Sue, for arranging this event and inviting me. I'm going to talk to you about incentive mechanisms. That means you can expect to be collecting money. And societal networks are, I will tell you what they are. It's a research area for us at Stanford, and they include transportation networks as a very important focus, but I'm going to enable. Yes. Thank you. So if we look at, we all seen pictures like this, and whether it's the roads or public transit systems, there seems to be no room anywhere to make progress. And if you phrase it differently so that we can look at it at a demand and supply type equation, and this is true for all the networks that we see. Oops. Thanks. So if you look at it from a supply and demand sort of equation sense, what's happening is that the systems are experiencing huge demand that's placed by us, and they all have a shortage of supply. So the question is, can we find some way to make this match, right? You can always try and increase supply, but it's very expensive and time-consuming. So it costs about $20 million to add a train in Singapore, and it's the sort of thing that one wants to think twice about. But even as you add supply, it doesn't really curb peak demand. It just gives people more options and tends to focus the demand in the peak times more than spread it. So our approach is to try and incentivize people, and we're going to sense a person's behavior in a way that you'll see. Increasingly, we're bringing you smartphones. And this data is used in an incentive platform. So in your mind, start thinking about a frequent flyer program, okay? So you make a trip that's logged. You get credits for it if it's of the desired type. And those credits are redeemable for dollars or dollar equivalents. And that incentive platform then interfaces back with the commuter and provides them information about alternatives and what they could do to improve their own commuting experience while also trying to earn back more money. Okay, so that's the architecture of our system. And what are the projects? There are 3 transportation projects, and this is, as I said, a big focus for us. And in Bangalore, Infosys Technologies is a software development company, and they have 20,000 employees. And in 2008, we launched a 6-month project to have those employees shift in time to off-peak commuting so as to escape the Bangalore traffic. And there's a paper on my website if you're interested, and that was successful. I'm not going to talk about it. InSync is ongoing. It's in Singapore. It's for the public transit commuters. and Capri, Congestion and Parking Relief Incentives. And it's for the Stanford campus. So if you just think of Stanford campus in your mind, or even have been there, it looks like a resort, right? Where's the traffic? You don't really see it, except in the peak times. And otherwise, you see all these students biking around. And so we're trying to, in a very precise way, Stanford has a problem that we're trying to solve, and it's funded by the DOT, for which we're grateful. And essentially, depending on the amount of dollars spent and which geography you're talking about, the goals that we've achieved are about a 9 to 20% shift in behavior, whether it's from peak to off-peak, or soon at Stanford, whether they're parking where we recommend them to park, off-center parking as we call it, or walking and biking, okay, mode shifting that is. And essentially, it's what I've said, it doesn't have to be that this replaces congestion charging type thing. It could be a complementary method. It could also be a complementary method to adding the supply. It doesn't mean you don't have to do that, right? So there are other projects we've done. One is on wellness, getting people to walk more. It's called Septacular. And then there's a corporate knowledge platform. This is to get people to learn more within an organization, and for a knowledge-intensive business like Accenture's, this sort of a learning, it turns out grown-ups, like, when we were children, we respond to things like treats, right? We seem to go, learn a new lesson and get a nice treat in exchange, right? And we also get to play games, right? So that's why I'm going to tell you more about these projects. Here's some reactions. I'm going to skip through to the Stanford project. So Stanford, in an agreement with Santa Clara County, dating over 10 years ago, has these limits. We can't have more than precisely those many vehicles enter in the morning peak, nor the second number, 3,446 vehicles exit in the evening peak. Failure to comply to these numbers means Stanford has to pay a fine. Worse yet, forego the obtaining of building permits. Okay, and if you've been to universities, they don't want to do that. That's the last thing they want to do. Because, university buildings have this thing where your name here for a donor, right? So that's the last thing they want. And every trip, this is our commute club, and there's this push since that program. Stanford does various things, including pay people money not to obtain a parking permit. So it's the only university that tries to pay you not to get a parking permit, okay? And so here, and our project is to focus on the peak hour, but the way it's measured is the 16 gates that are a congestion cordon, and those are the ways in which you can enter or exit Stanford, and we're audited by a company on behalf of the county, okay? So with that, let me give you an overview of what the Stanford project looks like, just in 2 slides. Think of a geofence. As you drive, you break a fence. And currently, that break is detected through an RFID tag, a scanner. It's like Easy Pass, okay? So you drive, and the tag in your car will announce that you arrived or you're exiting. By the way, everything that's presented here is done by Stanford students. So they learned how to, do civil engineering work like poles, solar panels, and then learned that fog affects the output of solar panels, things like this, right? And then there are brown widow spiders inside the battery box, and things like this, right? And then for those guys, you have to use Windex. So just so you know, in case you see them somewhere, right? So when you break a geofence as you arrive, the reading is put in this database, which I'll show you a quick tour of, and you can look at your commuting history. And you can go to this reward mechanism and redeem your dollars, okay, or dollar equivalents. And coming soon, we have apps that are replacing these RFID scanners. And once students start working on this and start seeing the difficulty of dealing with RFID scanners, the first thing to think of is apps. That's great. So now we're going to have apps where when you come, the parking recommendation is going to come out to you like this. You can go to parking structure 4 or get the Gates building parking or something else for some number of credits. So this is an underutilized lot. You get 50 credits. This one you won't get any credits because it's already full. And this is, you get some other credits, okay? And so that's the idea, and it'll be read out to you, so you don't have to even, obviously, you don't want people reading stuff when they're driving. And so So that's the Stanford project. I'm going to show you a tour of the site. The apps are about to be launched. And they will also log people's walking and biking activity, and they get credits for that and as well. So in a single slide, InSync stands for Incentives for Singapore's Commuters. And it's a public transit project, meaning that for if you're a commuter that makes a trip from one station to the other, that's detected through your smart card scan, and that scan is made available to us by the government folks, and then this entire thing runs in the cloud in Singapore. So once the data comes in, you as a commuter can look at your credits earned. So for every kilometer that you put on the system, you get a credit. In that sense, it resembles an airline miles program. And for every off-peak trip, you get three times the credits. Okay? And then you can look at the history of credits you earned, and you can redeem your rewards. So that's the InSync project, and this sort of overviews all the things that I wanted to say to you, and I'll just give you a quick tour of the site. Yeah. So if you go to the Stanford, if you're a Stanford commuter and you go to your account, you will see this is the landing page. Okay, you can track your activity. By the way, this, Denise Murphy is actually part of the administration of this scheme. So when you see dollars here for her, they're not real dollars. She can't collect them because she's one of us. Okay. And so track activity, so it's a demo site. She can track her activity or redeem credits or view these rewards, okay? And you can recommend friends and earn bonus credits, okay? And in Singapore, 70% of our commuters are now coming through the Recommend a Friend program. And I should have said we are in excess of 40,000 registered participants in Singapore, okay? And so at Stanford, we have 2,000 people registered. And you can look at a status meter. This, again, resembles an airline miles program. You could be, for your good deeds, you accrue status, and the amount of good deeds you're doing just ratchets up your status level from either a regular member or what we think of as bronze or silver or gold or platinum. And I will show you how to redeem the rewards in a second, but the rest of it is, so you can look at your friends. You can see that some of our friends are doing really well, like, this person's platinum, this person's silver, that person's gold. And friends have a huge influence we found in our research. If your friend is platinum and you're silver, for some reason or the other, we don't seem to be able to stomach that, right? We aspire we compete, okay? And that's just who we are, okay? But it does have a positive effect. I mean, I'm presenting it as competitive, but I think it's actually more of a collaborative thing where friends tend to inspire each other is the better way of thinking about it. I'm going to reload this page. So what you can see at the bottom here is that somebody won today, October 11th, Bay Area time, $2 on, I'm going to show you what the spinner is. And so somebody won $2, somebody won $5, somebody else won $5, and so on. And this is happening, in real time. And so if I reload this page, and I hope I wasn't logged out, what you can see, yeah, it's easy. That's the nice thing about this is it's a really, so therefore it's updated, and probably somebody else has won money. Still only 7:29 a.m. Okay, good. Let me go back to the, so now that you've earned all your credits through your good deeds at Stanford, how do you cash out? And so here's a central piece of our work. Because these incentive payment mechanisms, you don't want to have a lot of dollars to give away. You want to make a small amount of money go a long way. We use the idea of lotteries, but make it much more transparent, because people don't understand what it means to win $5 with 1 in 100 odds. It's actually not obvious. So that's one thing we've been doing, and we do this through a game of chance. And you take your credits, and you go to this game of chance, which is just chutes and ladders. And so this is somebody's account. It's a fake account. And their piece is over here, and you can click. So every time I click, it costs 5 credits for a click, okay, per click. And it'll subtract from my the credit balance, right? So you can see that this is moving. And let me just play out all the credits so you don't have to keep clicking until you win something. So if I play out all the credits, I see that this time I won $0, okay? So the lottery wasn't favorable to me, okay? But no matter, we can do this again and see what we win. And this time, hopefully I'm more lucky, I won $10, okay? So this is a lottery, as everybody can see, right? And again, keep in mind that we're not giving lotteries that make people retire from Stanford, and that's not our way of combating congestion. It's really to nudge them and change their lifestyles, not their lives, okay? So that's the whole of it. And with this, I can show you one last thing about the dashboard, which I had thought. So from the operator of the system's perspective, you can look at what's the effect in terms of shift effects, the analytics. So here you can look at the population breakdown. Currently at Stanford, there are these many women and those many men and so on, and faculty, staff, student breakdowns are. The majority of our participants is staff, and students is the second biggest group. Faculty turn out to be stubborn. To my chagrin, I'm finding that that's the case. This is the shift. So what you have to notice here is that we're incentivizing people to avoid the 8 to 9 a.m. morning peak time. They only earn credits in the shoulder time on the left or in the shoulder time on the right if they arrive in those slots of time. So this is like a parting of the Red Sea. You can see that. The before data on this aggregate, not for our commuters in the program, because we don't have that, looks more like this, right? And so this is people shifting out of the peak. And the other nice thing about something like this is you can see how the different constituencies are doing and what's happening at the different gates. So this is sort of thing you can get detailed analytics. Faculty are not many. They seem to respond, but if 1 or 2 of us respond, it would look good. But on the other hand, staff clearly prefer to come before the morning peak and leave essentially before the evening peak. Students, of course, like to come after the morning peak and leave after the evening peak. Okay? Thank you. That's it.
Now it's your time. That was a really engaging set of 3 conversations that definitely connect with each other and to our challenges in this region. So we've got a roving microphone. Because of our recording, audio and video, I do want you to please wait till this comes to you, and then here you go. And then briefly state your name. We're going to keep questions short so we can get lots of them in. Who would like to start us off? Yes, we can start right here in front. Alan?
Thank you. Alan Mellis. I have a brief 2-part question. Number 1 is, do you know what the number 1 capacity problem is with Chicago Transit? Hi, I'm Alan. Is it on yet? Yeah.
Yes.
Hi. I'm Alan Mellis, and I have a short 2-part question. Number 1 is, and you've already got a preview piece, you heard me, what is the number 1 capacity problem for transit in Chicago? The answer is bus bunching. Okay? But my real question, and that you can answer that if you like, if there's any solutions out there. But I'm also been very interested in wayfinding, and I was curious of the non-mobile phone, smartphone applications. What are you aware of on-site wayfinding? So if someone comes from a foreign country and gets to an L stop and wants to get someplace that without a smartphone, I can understand as smartphone applications. Are there examples where I can say I want to get to here, and if it's kiosks or what have you, as well as train arrival times and connections and stuff? Thank you.
Any comments? They're not. We know you're not Chicago
Right.
experts, but
So I would like to know and use this system myself, is what I was going to say, because I'm not from here, but I can speak to a system that I know, I've got to know rather, in Singapore. It is well appointed. You can navigate yourself, and it's not difficult to think of such a system here. And I understand that the L is internally well navigable, but it's across the systems where it's actually not that easy. But I don't know any more than that.
fair enough.
I'll take a crack at the bus bunching issue. So I guess the main reason for bus bunching is because of congestion on the roadways. And then also, usually the first bus gets filled up and it takes longer for people to board and everything. So I think transit signal priority might be able to help out with that. It could be conditional to try to move your bus that's holding everybody up to move them through. And then perhaps also being able to monitor passenger loads in real time and then be able to provide that information to travelers waiting at the bus stop to let them know that this bus is filling up, but there's a bus just 2 minutes behind this one, maybe something like that.
That dynamic information.
I think another example, which might be a good one, I think it's Barrett, where again they have interactive kiosks where you can get a lot of this information, and it has some interesting features where it also gives you information about the neighborhood. So if you're at a bus stop, what does this neighborhood look like from a cultural perspective? Local bands can put in their samples and so on. So very interesting things like that, but I haven't seen that in a widespread way.
I'm going to jump in with a quick question for Stephen. With the pilot cities that you've worked with, I know you mentioned that the lead agency is different in different places. Because of the complexity in our region, any recommendations about what you have seen work as far as the glue or the magnet to bring people to the table and keep them at the table? And first, I'd like from the U.S. perspective, and then perhaps there's a international perspective that the other panelists have.
For working with our pioneer sites, what it really came down to was the champion who was really most gung-ho for ICM, that had the strongest personality and the strongest belief in ICM. So in Dallas, it just happened to be Dallas Area Rapid Transit. Most of the other sites were led by the state DOTs. Mm-hmm. But that's pretty much what it comes down to is the champion in the region.
And for many of you, is it important to have shared benefits very clearly defined up front? In other words, even if when there is a dynamic leader calling people to the table, kind of the what's in it for me problem, does that come up in other systems, or even it could be even departments competing against each other when you're working with the asset department and they're competing for dollars against some other function of the agency. How do you create that kind of we're all going to win by collaborating mindset? Naveen?
It's a hard one, and because everybody, when you show the benefits of such common systems, everybody likes it, but at the end of the day, they don't want to give up control, or they want to be the host system to manage it for everybody else. Certain places where it's worked well is they've got a different organizational design, and some of them have switched to this design to get these efficiencies. So, for example, Singapore has one transportation entity, which is the LTA, Land Transport Authority. It has control over all transportation, regardless of mode. So,
it's easier in Singapore.
That's one. But if you go to London, they've got again TfL, Transport for London. Again, they've got a very broad purview of it. So similarly, other cities who have been seeing the benefits of such an approach, Dubai changed over to RTA, where they dissolved every of these individual entities and created one. So, one is where one agency is very strong in a region and they can get everybody to the table. The other approach that's worked elsewhere is just have one entity that has full responsibility to make things happen.
I think it's an important message for us to hear because this is our competition.
So when the ICM demonstration is completed, because we're providing the funding for the capital and the operating for 18 months, it'll be up to the sites responsibility to continue the funding for it. So I don't really know what their plan is. Each site is supposed to produce an operations and maintenance plan. So hopefully that'll be defined in that. Early on in the initiative, when we worked with the transit agencies to try to get them excited about it, we heard from a number of transit agencies saying, well, our budgets are so tight, we'd love to participate in this, but we can't always do that. But they did see that during certain situations, if there was like a major incident on a freeway, they'd be willing to work with the state DOT to improve their service. And then what the benefit for them would be increases in revenue if they had the spare capacity. Now, there's some locations that just don't have the spare capacity, like in peak hours. An example of that is WMATA, because they were one of the pioneer sites. But that's just some thinking that we went through. So more of the more progressive transit agencies across the United States, they've been very enthused about being involved in ICM.
Balaji?
I think one thing that I'm seeing, and I think a path forward between the siloed organizations is building a common platform of some kind and just opening APIs out. This is essentially what
API.
Thank you. Application programming interfaces is that the right data comes in and the right transactions take place. This is also how you build any large-scale system, is that you have different modules and you just want the minimal. You want to build stable and clean interfaces between them, and that's more or less how you could have everybody contributing, but then there's some central clearinghouse. Essentially, it's the sort of platform that we're trying to build at Stanford. So some of the walking and biking is coming from a wellness initiative at Stanford, not the parking and transportation folks. Right? So it sort of becomes a platform at that stage.
Excellent. Other questions? Yes, right here. Can we bring the microphone over? Thanks.
Ryan Shapiro from Veolia. This question is for Steve. Could you elaborate on the technology transfer? I would imagine that's for private industry, and in particular, are you selling the technology? Is there a licensing fee? Elaborate on what the purpose of the technology transfer is.
So one of the goals of the US DOT, at least moving forward, is to have open data and open source. Unfortunately, that's not the case for the ICM initiative. So the private entities that are working to develop the decision support systems, that is proprietary information. However, we have emphasized to both of the demonstration sites that any data that they have will be available for third-party providers in case they want to develop any interesting applications as far as like traveler information. So that is one thing that we are pushing.
Thank you. Okay, we'll go over here. Thanks.
P.S. Sriraj from the Urban Transportation Center, University of Illinois, Chicago. This is a question for Professor Prabhakar. I couldn't help but notice the shift in behavior while it's pronounced for the peak, but it seems to be staggered more towards the just before peak. There's a peak there.
Yeah.
So you're essentially shifting it to a different hour, and I'm sure there are still ways to go with your experimentation, but I'm wondering if you have any thoughts on that.
Yeah, no, if you look at if you superimpose the data on all the participants in the scheme and those that are yet to sign up, the peak is just shifted across all of them just right. You have to keep in mind that incentive program, first thing is an opt-in basis, people come in. Second thing is on any given day, not everybody is performing the same way. Several people don't even come to campus every day. The one way in which we're actually looking at exactly what you did, and it's embedded already in the scheme here, is there's something called a boost day. And we start with the idea that congestion is, you just need to move 10% of the load. Then you say to this set of participants, your Monday is your special day, and to the other set of participants, Tuesday is your special day, and so on. On the special day, they get extra credits for making off-peak trips, okay? And so everybody takes turns making off-peak trips. On the other 4 days, they can do what they want. This is the incentive version of a scheme which is used in many countries, where depending on license plate number, you don't get to drive on one or more days of the week, right? This is the incentive version of it. And you have to keep in mind this data is aggregated over months, 3 or 4 months. So if you now break it down by the week, you'll see the effect I'm talking about.
Joanna up front, thanks.
Joanna Trotter with the Metropolitan Planning Council. My question is also for Balaji. I'm just curious, as you're monitoring this, is that you talked about the health initiative, for example. I'm just curious about human resource policies and class scheduling shifts, and if then that gets captured here, and how you can compare the incentives versus the policy changes at Stanford.
So Stanford has flexible working hours, and for several people that is literally flexible working hours. You've seen the students. This is amazing, the students are actually even coming at after 9 a.m. This doesn't happen. Okay, not my students, let's say. Okay, but the thing is that that's the sort of flexible environment that's increasingly available. But you have to keep in mind this is a nudge, meaning a nudge as opposed to a shift. A shift would be something substantial. A nudge is something that's small. So you don't have to shift by more than 20 minutes to get a congestion out of it. Not everybody has to change, and not by a whole lot. We're not asking people to come at 5 in the morning. We're just asking them to come at either 7:15 or 7:30 instead of at 8. Right? So it's a small shift on some days, and that's what is enough to make congestion, get a congestion run.
Who did I miss? Hands over here or there? Okay, I've got a few people to thank. First of all, our sponsor for today was Harris Bank. Unfortunately, we don't have a representative here for Harris to give a round of applause to, but I just want to give them a special recognition because they've been an active partner with MPC for many, many years and helped us shape today's program. We also want to recognize the many people behind the scenes at MPC who help make these things work. The lead on this was our project manager, Chrissy Nichols. Those of you who work with us on transportation undoubtedly are already working with Chrissy, but she's got great expertise on innovative finance, emerging finance tools related to transportation, and is deeply involved with all of our projects. So thank you, Chrissy, for identifying these wonderful speakers and working with your colleagues to pull all of this off today. A reminder about the survey, please. We do more than 15 roundtables over the course of a year, plus other events, sometimes in partnership with other organizations. And if you tell us a little bit about what you need, what you're looking for, what works, we will continue to try to respond to that. And it's really helpful for us as we're in the midst of planning for next year, where we want to do even more. And then finally, to our panelists, you've been terrific. I think we set a high bar to help us understand your world and your work, but also translate it to our challenges here in Metropolitan Chicago, and you've very much helped us do that. So Balaji and Steve and Naveen, all three of you did a lot of preparation and were wonderfully entertaining and informative, which is no small feat. So let's give them a warm round of applause and thank you. If you're not already on our mailing list, just drop off a business card in the fishbowl as you depart. And also you can just leave your lunch boxes under your chair. We'll take care of them. Thanks.